Assalamualaikum warahmatullahi wabarakatuh to Dr. Norshida binti Muhammad Ali. My name is Noran Kavili Kamaruzaman. Today, I would like to show you a symmetry element and operation involved in a molecule that I have chosen, which is SF6, or can be known as sulfur hexafluoride. Okay, now we will look into this molecule, which is sulfur hexafluoride SF6. In this molecule, we need to identify the symmetry element and the operation involved. So the first thing we need to do is we need to find the rotational axis. For me, I want to label this molecule so it can be easy to identify, to see. Oh my god. Okay. So now let's say that I want to rotate 90 degrees within my molecule. Means that from this sulfur to the sulfur, or from the sulfur to the sulfur. So let's say that I will rotate 90 degrees from the top to here. So I will rotate 90 degrees. So look that I will get the same configuration. Okay, let's say that I want to rotate from here. So I rotate 90 degrees. Also, I can get the same configuration. Even if I rotate anti-clockwise, I'll get the same configuration. So this means that I can rotate 90 degrees within this molecule. So we can assume it as C4 axis. Okay, now we need to label here where is our C4 axis. Okay, we can label it from this. C4 axis is here, C4, here also C4, here C4, also C4, and here C4. Okay, now we will find other symmetry element, which is C3 element. If we look at this, C3 element means that we need to rotate 120 degrees. So if we want to rotate 120 degrees, means here we will take a look. If we rotate the configuration also the same, which is fluorine also located at the same place, and also from the top we can rotate 120 degrees. In this case, we have 4 C2 axes, so we can label C2 axis at our diagram. So the C4 the C2 axis is at here, here, and here also C3. Okay, now after determining the rotational axis, we need to determine the plane of this molecule. Because these molecules are octahedral molecule, which is mean that this molecule is highly symmetry. When it is highly symmetry, this molecule doesn't have vertical plane. So we must find the horizontal planes based on this molecule. Okay, based on this molecule, we can identify 3 horizontal planes. Okay, if we cut this molecule through this or through this, we can get the same configuration. Also, when we cut through this from here or here, we can get the same configuration. And when we cut from here also and here, so we get the same configuration. Then there is 3 horizontal plane involved in this molecule. So we can label in our diagram as horizontal plane, which is here, also here, as horizontal vertical. So, and also this shape also have diagonal vertical, which is involving all 6 atoms of fluorine, which we can rotate. Means like we can from here, here, and so on. So we need to label our diagonal plane in this diagram. And here also, and through our C3 is this. So if we count here, we can get 6 plane of diagonal plane. So now we need to find the point of symmetry. So we want to know if this element molecule have point of symmetry. So if we look at this, let's say that the sulfur is our point of symmetry. So if we inverse this fluorine to here, we will get the same fluorine. If we inverse here, we also can get the same fluorine. Also back at the bottom, if we inverse it to the above, we also can get the same configuration. Means that they are identical to each other. So the point of symmetry is at the sulfur. Which is identical to each other. So now let's write all the symmetry element involved. So the first one, we want to write the C4 axis. We have 1, 2, 3 C4 axis, and we have C3. We have 4 C3, and we have the horizontal plane, which is we have the yellow one. We have 3, and we also have diagonal plane, which is we have 6 total here. 6 diagonal plane, and we have identical, which is the point group, the symmetry element, the point of symmetry for this molecule. So the point group for this molecule is octahedral because it have horizontal plane, and this molecule are octahedral. Okay, that's all.